Question 5 is arguably where this paper steps up in difficulty a little. But it is quite a common question type, so it's well worth being used to grappling with problems of this nature. A camera at point C is 3 metres from the edge of a straight section of road, as shown in the following diagram. The camera detects a car travelling along the road at t equals 0. It then rotates, always pointing at the car, until the car passes O, the point on the edge of the road closest to the camera. The only piece of information missing from this diagram, therefore, is that COX is a right angle. A car travels along the road at a speed of 24 metres per second. Let the position of the car be x and let OCX equal theta. It's all on the diagram for you. Find d theta dt, the rate of rotation of the camera in radians per second at the instant the car passes the point O. So immediately what I'm thinking is that I'm going to need to use the chain rule, because I can't come up with an expression for theta necessarily at the moment, but what I can do is I can write d theta by dt as d theta by something times something by dt. And I look at the information that I'm given the car travels along the road at a speed 24 metres per second. That is the rate at which it covers this distance, OX, is 24 metres per second. So if I call that distance x, then I have dx dt, change in x over change in time. And so if I fill in my variables using my chain rule, I have d theta dt as d theta dx times dx dt. dx dt is easy, that's just 24 metres per second. d theta dx I can write nice and simply using trigonometry. I have my opposite OX and my adjacent CO to my angle theta, so tan theta is equal to OX, which I've just called x, divided by 3. So x is equal to 3 tan theta. Now I want d theta dx, but I think actually easier for me is just to differentiate both sides with respect to theta. I don't particularly like playing around with an arctan, which is equal to 3 sec squared theta, and therefore d theta dx is just 1 over 3 sec squared theta. So I have 1 over 3 sec squared theta times dx dt, which was 24. 24 over 3 is 8, so I have 8 over sec squared theta. Sec theta is 1 over cosine theta, so I have 8 cosine squared theta, and it wants the rate of rotation when the car passes point O, which is when theta is equal to 0. So when theta equals 0, d theta dt is equal to 8 times cosine 0 squared. Cosine 0 is 1, so that is just equal to 8. If I look at the mark scheme, it gives a couple of different methods. It sets OX to x, which I think is very sensible. Then it differentiates x with respect to t, that's straightforward, and uses a chain rule, and gets 3 tan theta is equal to x using trigonometry. And then either it uses my method, differentiating x with respect to theta, then inverting that to get d theta dx, or it writes theta as arctan x over 3. You do have the result for differentiating that in your formula booklet, and so you can then work with this subbing in x is 0. But for my money, definitely much easier to find dx d theta and then take the reciprocal of that value. Note that they're accepting minus 8 radians per second because you could choose to define the positive direction as either x towards O or O towards x in the question. I chose, in this case, to choose the positive direction as x towards O. So, another 6 marks sorted.